In this example, we want to factor the following expression. Now, this is a complicated factoring problem, far more complicated than the factoring you probably learned in, say, your intermediate algebra or even college algebra class. But we can use the factoring strategies that we have learned previously and apply them to this more complicated problem, even though you probably haven't done a factoring problem quite this complicated yet. But this is the type of factoring required in calculus, so we want to get ready for this. So before we jump into this problem, let's look at a simpler factoring problem so we can take a look at our factoring strategy. So for example, let's just say we were asked to factor 8x to the fourth power minus 2x to the third power. We want to factor this. To factor an expression means you want to rewrite the expression as a multiplication problem. So you want to rewrite this as a product. And when we factor, we generally are going to figure out what the greatest common factor is between the two terms. Now we see two terms here. So we have 8 and 2, and the greatest common factor between 8 and 2 is 2. That's the largest number that divides into each of those numbers evenly. And then we also have the x to the fourth and the x to the third, and the greatest common factor there is going to be x to the third power. Remember, when you first learned to factor, maybe you were taught to actually rewrite x to the fourth as x times x times x times x, and x cubed, which is x times x times x. And then we see that the greatest number of x's in each of these would be 3, and therefore x times x times x is x cubed. It's probably been a long time since you saw factoring described in that way, but it's really important that you understand the basics so we can then apply it to this more complicated expression. So if 2x cubed is our greatest common factor, then that's what we're going to be factoring out. We're factoring out a 2x cubed. Here you can see we're rewriting this as a multiplication. And essentially, to figure out what remains, you're dividing each of these terms by 2x cubed. So we can see that 2 divides into 8 4 times, and x cubed divides into x to the fourth x times, so we'll be left with 4x. If we were to distribute this to check this first step, 2x cubed times 4x would give us indeed 8x to the fourth, what we wanted here. And then we have minus 2 divides into 2 once, and x cubed divides into x cubed once, so we would have minus 1. And again, if you were to distribute and check that, 2x cubed times 1 is just 2x cubed. So this would be our factored form. So now, that's a much simpler problem, but let's apply the strategy to this more complicated one. And the whole idea in showing you this is to have you understand how we're going to get that greatest common factor, in particular, the x cubed. So if we go back to what we started with over here, the 8x to the fourth minus 2x cubed, notice we chose x, but we chose the x that had the smaller exponent. We chose x to the third power as our GCF, not x to the fourth, but x to the third. Remember, because the most number of x's that both of these had in common was 3. So we're always going to be choosing, in this case, x raised to the smallest power. The smallest power between those two terms was 3. So let's apply that now to our more complicated factoring problem over here. There are still two terms. So we have one term here, 8x to the negative 1/3 times 2x plus 1 to the third, and then we have 10x to the 2/3 times 2x plus 1 squared. So we'll determine our greatest common factor. So again, between the 8 and the 10, the greatest factor that divides in evenly would be 2. Then we have x to the negative 1/3 and x to the positive 2/3. So here's a great example where we have a base of x. They're both a base of x, but we have an exponent of a negative 1/3 and an exponent of a 2/3. So here we're going to take the smaller exponent. So the smaller exponent is going to be the negative 1/3. Therefore, x to the negative 1/3 will be our greatest common factor between those two terms. And then we'll move on to the 2x plus 1 cubed. And over here we have 2x plus 1 squared. The base is 2x plus 1. And again, we're going to apply our strategy where we're taking the smaller exponent, we have 3 and 2, and the smaller exponent would be a 2. The greatest common factor there is 2x plus 1 squared. So that's how we arrive at our GCF. Now, whatever our greatest common factor is, remember we're factoring that out, so that will be rewritten out here. 2x to the negative 1/3 times 2x plus 1, the quantity squared. And then we want to go ahead and factor that out and determine what remains. I recommend that you go ahead and write the division because it will help you in the beginning until you feel more comfortable doing these in your head. So we're dividing each of these terms by 2x to the negative 1/3 times 2x plus 1 squared. So we're going to simplify these division problems and see what remains. We have 2 dividing into 8 4 times. X to the negative 1/3 divided by x to the negative 1/3 is just 1. And then we have 2x plus 1 squared. We'll divide into 2x plus 1 cubed, and we'll be left with 1. So that would be 4 times 2x plus 1 to the first power, plus 2 divides into 10 5 times. Now here we have x to the 2/3 divided by x to the negative 1/3. So remember, in this case, because they both are a base of x, we're going to subtract our exponents. So the numerator, the exponent is 2/3 minus, down below the denominator, the exponent was negative 1/3. We're subtracting our exponents. So 2/3 minus negative 1/3 is really 2/3 plus 1/3, which is 3/3, which is 1. So that means we're really going to have x to the first power there. And then 2x plus 1 squared divides evenly into 2x plus 1 squared one time. So that leaves us with a 1. So this would be our factored form. I always would recommend that you go ahead and simplify what you have, what I have written here in green. So I'll go ahead and distribute and combine like terms. So that would be 8x plus 4, and then we have plus 5x, and that would give us 13x plus 4. So my final factored form will be 2x to the negative 1/3 power times the quantity 2x plus 1 squared times the quantity 13x plus 4. And again, this is factored because we have rewritten this as a multiplication problem. So it was originally an addition problem, and now we've rewritten it as multiplication, and that's what it means to factor.